Hello, CS200 students. This is Sam, as I'm sure you've figured out by now. So today I will be talking about this problem that we talked about in class, where we want to find the number of strings of length n, where the characters we're using are 0, 1 through 9. And we're first going to talk about this version, and then we'll talk about the version where no 2 can be followed by a 3. Because this problem is very similar to one on your homework. I believe it is part 4 of P6, where Rose is looking at the star IDs. And in talking through this problem, I'm going to go a lot slower than we did in class, and I'm going to go a lot more in what I will consider to be painfully excruciating detail. So the first thing is, what the heck does this question even mean? What is a string? What does length n mean? N is a letter, not a number. You can't have a string of a letter length. And what do I mean that it uses the numbers 0 through 9? So first thing I'm going to talk about is, what is a string? So y'all are familiar, hopefully, with this idea of a string from Java. In Java, a string is just a sequence of characters in some order. In Java, a string, we denote a string by putting it in double quotation marks. We're not quite working in Java right now, so I'm not going to bother with that, but the idea of a string is the same. A string is just a sequence of characters. I'm going to write that down. That's how important it is. I never write anything down. So a string is a sequence of characters. And for example, x, x, y, z is a string. A is a string. Strings have length. That's the number of characters that are in the string. So here we have 4 characters. Here we have 7 characters. I guess I should probably underline this because I'm explaining what that is too. So that is a string. A string is just some number of characters. And these characters can be anything in general. I mean, we could have 7, 7, 4. That's a string of length 3. We could have A, 7, 4. That is a string of length 3. We could have star, box, ampersand. Well, I mean, like, this isn't a usual character that we use, but it's still a character. So this is a string of length 3. So now we get to this idea that we're only going to allow use of certain characters. So in general, when we talk about strings, we define them to be over some alphabet, some set of characters that we are allowed to use. So when I say that we can use the number 0 through 9, I mean that every character in the string has to be one of these numbers. So 0, 1, 1, 2 is a valid string of numbers 0 through 9. 0, 7, 7, 7, 7, A is not, because A is not a number 0 through 9. So this would be over 0 to 9. But we could have other strings, yeah? I could say that it could be over the numbers 0 through 9, or you could have letters. So 0 through 9 and letters. So then 0, 0, 0, A, 7, 4 would be a valid string of length 0 through 9 and letters, because all the characters come from this set of characters. I am only using things that I am allowed to. In Java, our strings have to be over... it's this with some extra things and a whole bunch of other stuff. I'm not going to talk about that here. Ask me on Piazza if you care. And now that is a test of who actually is interested in computer science and who's just here for a good grade. So, yeah, so that's the idea, is we have just a bunch of numbers in a row. And we want to know how many there are of length n. So this is the first time in this class we're doing something really mathy, really theoretical. So I'm going to talk, for those of you who have a good math background, this will probably be redundant and a little bit low level for you. But for those of you who don't, hopefully this will be helpful in understanding what's going on. So when I say I want to count something involving n, I want to come up with a formula that will be true for every value of n. So let's say I want to count the number of factors is a bad one. The number of, I didn't actually think of an example before. Let's say the number of let's do this one. Strings of length n over 0 and 1. So now our strings can only be 0 or 1. Up here we did 0 through 9, now we're doing 0 through 1. So the only strings we can do involve 0 and 1. So when I say that I want to find the number for length n, that means I want a math formula. I want it to be like 5 times n, strings of length n. And then when we plug in 3, then it'll be 5 times 3. So it's 5 times n of length n, and 5 times 3 of length 3. So the idea is that we want to find a formula for this that is true for every value of n, because maybe I don't know right now all of the values I'm going to care about this in the future for. Maybe I'm designing a hard drive and I want to know how many strings of length 32 there are, because that's how many values of integers I can have. But maybe in 500 years, we're going to have hard drives with 1 billion bits where we store our integers. And so then we're going to want to plug in 1 billion for n. And so if I just calculated for one value, then 500 years from now, Sam is going to be sad because he's not going to know his number. So if I figure it out for n, then I will always be able to calculate it for any given number by just plugging in 3 for n. For example, let's say that the number of pizzas I eat on a day is given by I eat 1 on day 1, and then I eat n plus 7. No, that's a lot of pizzas. Let's not do n plus 7. I'm watching my figure. Let's do n minus 1 on day n, where n is greater than 1. So some of you have sort of gotten this idea that when I say day n in a description like this, I mean excluding the ones that I've given you. Because you'll notice that 1 minus 1 is 0, not 1. So I've explicitly said here n strictly greater than 1, because this base case is something different. That is what I've told you. But for any arbitrary day, it's going to be n, or n minus 1. So if this formula were correct, now I can calculate how many pizzas I'm going to eat on any given day by just plugging in this number. So let's say that on day 15, how many pizzas am I going to eat? Well, it'll be 15 minus 1, which, as you all know, wait, I'll give you a second, 14. So 14 pizzas on day 15. So we can use this formula to calculate something. And now I could plug in 100 for n, I could plug in 1,000,000 for n, and this formula would still work. So that is the idea here, is that we're going to figure out this general formula for the number of strings of length n. But because we're computer scientists, we don't want a function. We don't want a math function. We want a computer program that computes it for us. So, and that'll be nice because some of these things won't have nice math functions. They'll have weird recursive definitions. And it's hard to solve recursive things by hand. Computers are really good at it though. So we're going to come up with a recursive math formula for this, and then we'll be able to make a program to calculate that for us. So the number of strings of length n that use 0 through 9. If you are not comfortable with what the question is asking, now would be the time to pause the video, go to Piazza, ask, wait, what's a string? What's length n? Why is he using a letter? Or go back to the video, watch it again, but in half time so that it'll look really slow and all my movements are weird. So if you made it to this point in the video, I assume that you are comfortable with this question. Now, let's try to answer it. So, strings of length n. So let's start by thinking about strings of length 1. How many strings of length 1 are there that use these letters? Well, if it's length 1, it either starts with a 0 or a 1 or a 2 or a 3 up to 9. So there are 10 possibilities for this digit. So if n equals 1, then the answer is 10. If n equals 2, how many possibilities do we have? Well, oh shoot, now we have to, so for each choice of the first digit, there are some choices for the second one. So the first digit could be 0. If the first digit is 0, the second digit could be 0, or it could be 1, or it could be 2, or it could be anything up to 9. So there are 10 of these. And then, if the first digit is 1, well, the second digit could be 0, the second digit could be 1, all the way up to, it could be 1 and 9. So again, there are 10 of these. So for each possible value of the first digit, there are 10 options for the second digit. So the total number would be 10 plus 10 plus 10 plus 10, a number of times that is equal to the number of first digits there are. Alternatively, we all know that repeated addition is multiplication, so there are 10 times 10 options. 10 times 10. Again, because there are 10 options for the first spot and 10 options for the second spot, and each one of these options could be paired with any one of these. So it could go 1, 1, 1, 2, 1, 3, 1, 4, so we multiply them together. This is the core idea that we're going to be using for all of this, is that if you have both of these free, you're allowed to choose anything for this and anything for this. The total number is then multiplied. So this is the case where n equals 2. There are 100. What about the case, the general case? For any arbitrary n, I want to calculate this. So again, the idea behind this is that we are going to write a formula, a math formula, that we can then plug n into that will calculate this for us. So I'm going to write a function. I'm going to call it d of n. And this is going to compute this thing, the number of strings of length n that use 0 through 9. So this is a math function. We are going to use math when we write it. So let's think recursively. So the idea behind recursion is we are going to take our problem and reduce it into a smaller problem that we will then solve by just pretending like this function worked. So the number of strings of length n, well, let's pretend that there are n of these. So then we can think about, okay, how many possibilities are there for the first digit? Well, it could be 0, 1, 2, 3, etc. up to 9. So there are 10 possibilities for the first digit. And then, so we have now, what we have left is some part of the word. Some part of the string, sorry. And so how many slots are there? Well, there were n before, and we have fixed one of them. So there were n, we removed 1, now we have n minus 1 spots left. So now the question is, well, we want to put strings in here, right? Like, we should go 7, 1, 4, or it could be 7, 2, 4. So now we need to count the number of strings of length n minus 1 that are valid here. Coincidentally, we already know that number because we're allowed to use this function. We are allowed to use this function even though we haven't defined it yet. So the number of strings of length n minus 1 that use this, that use these numbers is d of n minus 1. Shoot, sorry, I should have n. The number of strings of length n minus 1 would be d of n minus 1. The number of strings of length 5 that use these would be d of 5. So this is d of n minus 1. And like I said earlier, because we can choose any one of these, and we can pair it with any one of these, we multiply these together to get the total amount. Because, well, if the first digit's 0, then there are dn minus 1 options here. If the first digit is 1, there are dn minus 1 options here. Those are different, so we add them together. And we do that 10 times. So the total number would be 10 times d of n minus 1. And so 10 times d of n minus 1. So this is the recursive definition. But we need a base case because n going down by 1 eventually will get negative. It'll be negative infinity. It'll just keep going forever. So we need a time to stop. A good time to stop would be when d of 1, because we know how many strings of length 1 there are. We counted before, there were 10. Alternatively, we could have used d of 0. Now, I'm not going to explain this, but there is one string of length 0. That's just the number we need for the math to work out. You can trust me because I said so. If you really, really want to talk about this, like, make an appointment with me and we'll talk in great detail about it, but it is not worth it. Don't even, just pretend. So, now, it's that if n is greater than 0, or it's 1 if n equals 0. Cool. So, this is the idea. We're going to use the same idea for more complicated problems now. So let's say I modify this problem. So rather than saying all the strings that use 0 through 9, let's say I want to compute, I'm going to call it t of n, the number of strings of length n that use 0 through 9, where every 2 is followed by a 3. This is something we did in class. So what I mean by that is if there is a 2 in the number, then the next number has to be a 3. It can't be a 4, it has to be a 3. And by next, I mean the one to the right of it. So 8, 4, 4, 3, 2 is not okay because there is no 3 to the right of it. This is sad. The number 2 doesn't have to appear in the number though. It could be 7, 7, 1. That's fine because there are no 2's. So every 2 that appears is followed by a 3 because there are no 2's that appear. So let us attempt to use the same idea to solve this problem. So let's think base cases first. So when n equals 0, there's 1. Again, because I told you. When n equals 1, now we have a string of length 1. How many possibilities for this digit are there? Well, it could be 0, 1. It can't be 2, because if it were a 2, then we would have a 2 that's not followed by a 3. We can have 3, 4, 5, blah, blah, blah. So any number but 2. So there are 9 possibilities here. And then let's think about the general case. So let's think about t of n being in general. So this is where we're going to break things down. So first we're going to count the number of valid strings that start with a 2 and the number that don't. So when I say valid, what I mean is that it satisfies this condition. Because my set of strings is all the ones that satisfy some condition, and so I want to say, okay, they either do or don't start with a 2. Those are all the possibilities, right? It's hard to think about counting them otherwise because, well, if it starts with a 2, then the next number is fixed. So, like, we want to sort of break this down into 2 parts. And so what we're going to do is we're going to count them separately, and then we're going to add them together, and that'll be the total sum. It's as if, okay, so y'all can't see it, but I'm in my office, which some of you have been to, and there are a bunch of chairs in my office, right? There are chairs over here and chairs over here. Let's say we were trying to count the chairs in my office. So you can't see all of them at once because you're on the camera. So first, I could face you this way, and you could count these chairs. So you can see 3 chairs from there, yeah? I see one. Let me see if I can do this. 1, 2, 3 chairs. 3 chairs. There are 3 chairs on this side. And then I can turn you around, and you can look over here, and you can see, okay, now I see 2 chairs. 1, 2 chairs. So you saw 3 on one side and 2 on the other. So the total number? 5. Yeah, because 2 plus 3 is 5. This is that same idea. First, we're going to only think about the ones that start with a 2. And then we're going to only think about the ones that don't start with a 2. And those together are all of them. Because, so if we were to list them out, it would be like 0, 1, blah, 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 1, 1, blah, 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 1, 2, blah, blah, blah. So a bunch of strings, and then some of them would start with a 2 and some wouldn't. And so if these are all of the valid strings, some of them start with a 2, some don't. So we're going to count these separately and add them together. I am going to be done talking about this now, I promise. But if this idea confuses you, please post on Piazza, because you're going to need this a lot. Both in this class, in life, because like counting is important. So now let's think about how to count each one of these. So let's first think about the number that don't start with a 2. So what we're always going to do in these recursive problems is we're going to think about the first choice, or the first digit, or the first something first. So in this case, we have a string of length n. We're going to think about the first digit first. So how many possibilities are there for the first digit? So here we're not a 2 first. So how many possibilities are there for strings of length n that don't start with a 2 first? Well, let's think about the number for the first digit first. How many first digits are there that aren't a 2? Yes, there are 9, because it could be 0, 1, 3, 4, 5, 6, 7, 8, 9. 9. So there are 9 possibilities for this first spot. And then we can think about all of the remaining spots. So how many spots are left? Well, we had n total and took up 1. So now there are n minus 1 spots left. And now we want to count the number of valid ways we can fill those in. Because, again, we're going to first count this and then the rest and multiply them together, just like we did in the case where we didn't have this extra condition. So we can fill this in any way that is valid, that has 0 through 9 and every 2 is followed by a 3. How many are there? I don't know, that's hard. But we have a way to compute that without thinking. We can just plug in n minus 1 into the function. That is the number of ways, because this function works. We're just pretending like it works. We're taking this leap of faith that, yes, this function is correct. So now it is n times t of n minus 1, because t of n minus 1 is the number of ways we can fill this in. So that's the number that starts with a 2 first. So that's this second term. Now, what about the number that start with a 2? I might have said that backwards just now. This is the number that don't start with a 2. So what about the number that do start with a 2? So again, this is length n. And then what is the first digit? Yeah, 2, because it starts with a 2. And then the second digit has to be a 3, because we're only counting the valid strings. All the valid ones have to follow this rule that it's 2 and then a 3. And then how many spots do we have left? Well, we had n total, and then we got rid of 2 of them. So it was n remove 2, which is n minus 2. So how many possibilities are there for the first spot? There's 1 possibility. How many possibilities are there for the second spot? 1 possibility. How many possibilities are there for the remaining n minus 1 spots? T of n minus 1, because that's just the number that we're computing. Because, again, the magic of all of this is that we can just say this. We can just say, well, it's however many options there are that follow our rule. So now we have computed the number that start with a 2 and the number that do not. Now we just add them. So the total, t of n, is equal to n times t of n minus 1 plus t of n minus 2. You need base cases. We did the base cases already. Or did we? I don't remember. Doesn't matter. T of 0 should be 1, like always. T of 1 we said should be 9, because anything but a 2. So this is this example. So notice we haven't written code. All I wrote was a math formula. If you were to write code for this, it would be exceedingly arbitrary. So I'm going to write, just the most basic pseudocode. So I'm going to write a function. Let's just call it count. And it'll take an int n. So first we need our base cases. If n equals 0, then we return 1. If n equals 1, we return 9. And then otherwise, we return 9 times, it's just exactly this. We return t of n, which is defined recursively. 9 times, sorry, not t, I changed it to count. Count of n minus 1 plus count of n minus 2. And the only reason I changed the name was so that we could keep this differentiation between the math function and the program. So now we have a computer program, well, a pseudocode program that computes this number. So like I was saying before, now if I want to know how many strings of length 5 there are that satisfy this rule, I put 5 in for n, and it recursively computes it, because computers are amazing. If I put in 100 for n, it will recursively compute it. If I put in 1,000 for n, it will recursively compute it. Now, I've done it. I made it possible for us to answer this question for any arbitrary value of n. That is very exciting to me, and should be to you, hopefully. So, that's this problem. This is pretty close to what's on your homework. I'm going to just give you a slight hint in the right direction for this homework problem. So let's say we were to, I don't know, change, rather than 0 through 9, let's say you're only allowed to use 0 through 9 and there are no 4s allowed. No one likes 4s, so we're going to make sure that number doesn't appear. Now, when we did this this counting, first our base case will be different, right? Because now we can't have a 4 come in the first spot. So instead of a 9, it'll be an 8. Now, we do the same thing. So if it's length n, how many options for the first spot are there? Well, it could be 0, 1, not 2. It could be 0, 1, 3, not 4. So it can't be 2 or 4. It can't be 2 or 4, so there are 8 options for the first spot. And then how many options for the second spot? Well, again, it'll be t of n minus 1. And then the other case is not affected, the 2s and 3s. So again, it's 1 option for the first spot, 1 option for the second spot, and then t of n minus 1 options left. And these are added together. So, what if I were to also say it could be followed by a 3 or a, what number haven't I used yet? Or a 1. It could be followed by a 3 or a 1. So now, instead of just a 3 here, there are 2 choices. It could be a 3 or a 1, which means there are 2 choices here. So, again, first spot, there's 1 option. Second spot, now there's 2 options. And then the remainder, sorry, this should be n minus 2. Y'all were probably screaming over that. Then the remainder, there's t of n minus 2 options. Because again, so this is really, okay, 2, 3, a bunch of stuff, or 2, 1, a bunch of stuff. Each one of these, there are t of n minus 2 choices, so it's 2 times that. If I said that it could be followed by a 3, 1, or 4, well, I lied to you. 3, 1, or 5, then this would be 3 times that. So this is the general idea. All the numbers are wrong and I haven't coded anything. But also, in the homework, there is one additional condition that I'm not going to walk you through because you're smart and you can figure it out. So hopefully this video was helpful in sort of going over this problem and breaking things down a lot slower. If you have more questions, feel free to post on Piazza. I probably won't see comments that are posted on this video because I don't know how YouTube works. So if you have questions or more concerns, please raise them on Piazza as always. Have a great weekend and good luck with the homework.